Hello students, in this video I am going to teach the problem part of 2D viewing. In a world coordinate area, there is a specific part selected for display that is called window coordinate. That window coordinate can be displayed on a screen in a particular area that is called viewport. Now we are going to map the window coordinate onto viewport. Window is nothing but what we exactly viewed from the world coordinate, and viewport is nothing but where the selected content can be displayed. So we have to map the window coordinate image into viewport area. This is the formula we are using to convert window to viewport transformation. In a window, we are easily identify the x maximum and x minimum value and y maximum and y minimum value for this rectangular area. So in this coordinate shows the x window minimum and y window minimum value, and this coordinate gives the x window maximum and y window maximum. In the same way, viewport also a rectangular area that is reside inside the window. So it is also having the x viewport minimum and y viewport minimum, and x viewport maximum and y viewport maximum. Consider the window having the maximum pixels of 10 in x-axis as well as y-axis. Assume that there is a dot exists in the particular coordinate, that is 5, 5. Identify the x window minimum and x window maximum. That means you can specify the coordinate for each corner of the window. Then identify the x window minimum maximum and y window minimum maximum. So consider the viewport that resides inside the window. That means we are going to display the image or video in this area only. So we have to map the entire screen into this area. Here the image is simple primitive called point, that is dot. It has its own coordinate value. We have to map this dot into this part. So we know x window and y window coordinate that can be exist in this formula, x window and y window coordinate. We need to find xv and yv. So the remaining values we already know. So we know the x window minimum maximum, y window minimum maximum. In the same way, x viewport minimum maximum, y viewport minimum maximum. So apply this value here, we can get this form. So after simple subtraction, we can get xv divided by 6 equal to 5 by 10. Then xv equal to 30 divided by 10. So we can get the value 3. In the same way, we can apply the y coordinate value. We can get y viewport value also 3. So we found the new coordinate value that can be displayed in a viewport. That value is 3, 3. So we redraw the dot in this viewport at 3, 3. Suppose the object present in the window is a straight line. We can concentrate on the starting and end point. We can calculate the new coordinate value for the starting point as well as end point and redraw the straight line. Don't worry about the intermediate pixel. So in the same way, for any primitive, for example rectangle or triangle, they have the individual coordinate for each vertex. So we need to find the new vertex for viewport coordinate using this formula. Then redraw the image. In your examination, sometimes the problem is explicitly asked by giving the value. In a theory part, you can fix your own values for window as well as viewport coordinate, and you can choose your own primitive and you find the new coordinate value and redraw it in a viewport. So by using this problem, you can elaborate your answer in a theory part also. Thank you.